Welcome to section The Third Dimension. In this section we're going to take a look at an introduction to 3D and how we would go about rendering in 3D in LibGDX, and then looking at 3D lighting models, and then looking at 3D lighting and how to incorporate that into our game, and then looking at 3D lighting in LibGDX, and then using Blender to import 3D models into our LibGDX game. We're now going to take a look at incorporating 3D into our LibGDX game. In this video we're going to take a look at the very basics of 3D rendering in LibGDX using a completely different camera. So as you can see, I've reset my gameplay screen completely, and I've deleted the main menu screen. This is because now that we're going into 3D, pretty much everything is going to be different, so we may as well just start from scratch. And I've also taken out the main menu screen out of the main class as well. So first things first is to create our camera, and we're not going to be using the orthographic camera, we are going to be using a perspective camera. Let's just name this camera. We're going to set this camera equal to a new perspective camera, and we have three parameters here. We have a field of view, a width, and a height. The field of view is generally about 67, so we'll go ahead and put that. And that's if we're running a landscape game. We are going to change our Android manifest to landscape, so go in there and change the orientation to landscape. And that's a typical landscape field of view. You can of course adjust that to what you like, or even have an option in your game, but for now we'll just set 67. Now, because this isn't an orthographic camera, this isn't one of those that scales, we're just going to set this camera equal to whatever the screen size is. So gdx.graphics.getWidth and gdx.graphics.getHeight. And the camera position set needs to provide an X, Y, and Z. We're going to have this as 10F, 10F, and 10F. I'll tell you the reason in a second. We also need a camera.lookAt. So think of this camera as a physical camera in a 3D space, like if I had a camera on you in real life. And we're going to look at the origin, 0000. Now, the reason why this isn't 0000 is because if I'm looking at 000, how can I also be in 0000? So this essentially just offsets the camera up, behind, and left by these values, or sorry, down, and it will then look at this position. We also need a minimum and a max render distance, so how much are we actually going to be rendering, and the defaults LibGDX gives is 1F for near and 300F for far, but of course these are adjustable throughout the game development process, and again these can be toggleable options as well. Now we actually need, like a sprite batch, something to render things, and this is going to be a model batch. We'll just call this, no, we'll call it batch. We'll just call it batch. And this is going to render models on the screen, if you couldn't guess already. This batch is going to be equal to new model batch. Now, as a result, we also need, as you can guess, a model. Call this model, but also a model instance. Now the difference is that a model, we'll call this model instance, actually, we might get, it's a bit confusing. Now the difference between model and a model instance is that a model contains the graphical properties of the actual model itself. However, the model instance contains things like the scale, the rotation, and the position of the model. So for example, if I had a zombie type, then I would define the model as a zombie, but then I want the player to be attacked by 5 zombies, so I would have 5 zombie instances. The model is essentially the template, and the model instance is the actual thing. And before we actually start to define this, make sure you dispose this model down here in your dispose method. Now for actually defining this model, first we need a model builder. So just go ahead, and this is going to be very temporary, that's why we're just putting it here in the constructor, equals new model builder. And so our model is going to, from the model builder, create a box, and as you can see we have a lot of options here. It's pretty nice, but we just need a box. So create a box, and we have 3 different parameters: width, height, depth, material, and attributes. Width, height, and depth are pretty self-explanatory. We're just going to go with, I don't know, 4F for now, for each. We want a perfect cube. We've then got material. We're going to have new material, color attribute, not color, color attribute. As you can see, this comes from the com.badlogic.gdx.graphics.g3d attributes. So color attribute. Create diffuse, and as you can see, you do have these different color creations for the material. I don't really know how to describe this, but color creations, I guess. And we're just going to have this color, I don't know, oh, blue, because our player was blue in our 2D game as well, so how about blue here as well. And the next one, as you can see, is attributes. This is plural. We're just going to make this on a separate line because it's getting quite long now. This is plural, so we can have multiple. And one of them is going to be usage.position. And this essentially says that our model has to have a position when we make it. When we create a model instance, it's going to have a position. And also, we want a usage.normal. This just makes sure that, you know, generic things like lighting and stuff like that just works fine. And then we're going to finally create our model instance out of this model. Just simply model instance model. In our render method, we're going to set the gdx.gl viewport to 0, 0, gdx.graphics.getWidth and gdx.graphics.getHeight. This is essentially the canvas, and we want the canvas to start from 0, 0 and have a width and a height. And in 3D, no, LibGDX does not have that weird, you know, Y is flipped thing, so you don't have to worry about that. And like with 2D, we have this method that we don't really need to be concerned with, but we have it nonetheless. gl.colorBufferBit, but also gl20.gl_depth_bufferBit, because we do have depth now. And just simply batch.begin, and we need to intake this camera, and batch.end, like we've always had it. Before that, actually, camera.update. And we can now render our instance. Batch.render instance. If we go ahead and play, and as you can see, we do have our cube. We can't really tell it's a cube, it's more of a, how do I put this, mangled hexagon, and that's because we don't have any lighting.